What I find remarkable is that the universe started out as like quarks and leptons. We'll call it like, hydrogen. But I mean, I think there's maybe is some value to experimenting with different new technologies.
The world of technology and innovation has always been a realm of bold claims and transformative ideas. But few individuals embody the spirit of disruption as much as Elon Musk. His ventures have consistently reshaped entire industries, from revolutionizing space travel with SpaceX to transforming the automotive world with electric vehicles. Yet, in a surprising and unprecedented turn, Musk recently unveiled an invention that left even the most forward-thinking analysts and tech enthusiasts in shock: a new water-powered engine. This revelation threatens to eclipse the revolution Musk himself started, shaking the very foundations of the electric vehicle, EV industry, and sparking urgent questions about the future of energy and transportation. At Tesla's state-of-the-art research facility in Palo Alto, the unveiling event was electrifying. Musk, as expected, appeared with characteristic flair, stepping onto the stage in front of a room full of media representatives, investors, and industry leaders. Most were anticipating announcements on battery advancements, AI integration for Tesla's autonomous driving systems, or updates on Tesla's global expansion. Instead, Musk greeted the crowd with an enigmatic smile and unveiled a concept that seemed more like speculative fiction than science fact: an engine that uses water as its primary fuel source. The initial disbelief that swept through the room quickly turned to awe as Musk detailed the engine's capabilities and the underlying principles that made it possible. This new engine operates differently from conventional hydrogen fuel cells, which split water molecules into hydrogen and oxygen to create energy. Instead, Tesla's new water-powered engine harnesses molecular-level reactions in a way that Musk described as both efficient and environmentally neutral. He withheld technical details, citing proprietary technology, but emphasized that this approach would promise unprecedented energy output with minimal ecological impact. The implications were monumental. The electric vehicle industry, just beginning to hit its stride and scale up to meet global climate goals, was facing the very real possibility that this new water-based technology could render much of the industry's recent investments into everything from battery production to charging stations obsolete. The advantages of Musk's water engine were striking. One of the most compelling was its operational simplicity. Unlike lithium-ion batteries, which have limited lifespans and environmentally damaging production processes, this water engine promised a more sustainable alternative. The need for mining rare earth metals and disposing of toxic battery waste could be drastically reduced, offering a solution to one of the major criticisms of electric vehicles. The water engine's ability to use regular water, with no need for expensive electrolytes or chemical additives, made it even more disruptive. Musk showed a demonstration video where a prototype car was refueled from what appeared to be a standard water source, similar to a garden hose. This imagery powerfully reinforced the idea that in the future, recharging stations might be replaced by easily accessible water points. While this would require new infrastructure, it was less daunting than the challenge of building a global network of electric vehicle chargers. The ripples of Musk's announcement extended beyond Tesla. His new invention challenged the business models of major automakers like Volkswagen, GM, and Ford, which had only recently committed to electrification and poured billions into EV research. Now, these companies face the daunting reality of playing catch-up in a race they hadn't anticipated. Industry insiders began wondering whether traditional automakers could pivot to this new model, or if Tesla's leap ahead would prove insurmountable. From a geopolitical standpoint, the development of a water-powered engine had profound implications. The global race for lithium, cobalt, and other battery materials has created intense competition and strained international relations. A water-based energy system could drastically change the game, as countries with abundant freshwater supplies but limited access to battery materials could find themselves in a much stronger position. Conversely, nations that had built their economies around the mining and production of lithium-ion technology could see their industries dwindling if this new technology gained widespread adoption. Musk's vision extended beyond automotive applications, hinting at potential uses in industrial power, aviation, and even space exploration. He suggested that the same water-based energy principles could be adapted for spacecraft, opening new possibilities for deep space missions where water could be harvested from asteroids or distant moons. This technology could reduce the logistical challenges and costs of space exploration, potentially paving the way for interstellar travel powered by renewable resources. The crowd was captivated by this future-oriented vision, and investors were quick to respond. Tesla's stocks surged as analysts speculated about the long-term impact this innovation could have on the company's dominance in the energy sector. At the same time, stocks in battery manufacturers and lithium mining companies dropped sharply as fears of market disruption took hold. However, despite the excitement, there were immediate concerns about the viability of the water engine. While the concept sounded groundbreaking, many critics pointed out that it faced significant practical and engineering hurdles before it could be widely adopted. Skeptics questioned the durability of the engine, the costs of retrofitting existing vehicles, and whether the system could be scaled up for heavy-duty applications like long-haul trucking. They urged caution, pointing out that previous bold technological promises had sometimes failed to live up to expectations due to unforeseen challenges. Environmental groups, on the other hand, were cautiously optimistic. Unlike hydrogen fuel cells, which often rely on non-renewable energy sources for hydrogen extraction, Musk's water engine promised a far lower ecological impact. The potential to generate energy from water without harmful emissions could represent a significant step forward in achieving global sustainability goals if it worked as Musk claimed. In this sense, the water engine offered a cleaner, more scalable alternative to current energy systems, which still rely heavily on fossil fuels. The cultural and social implications of this technology were also profound. If Tesla's water engine could be brought to market successfully, it might democratize energy in a way few technologies have. By shifting from scarce mined resources to an abundant one like water, the power dynamics of energy production could shift from monopolistic corporations to a more decentralized model. This could have significant effects on both developing and developed nations, potentially altering economic growth, social equity, and access to technology in ways we are only beginning to understand. Musk concluded his presentation with his trademark blend of optimism and challenge. He outlined Tesla's plan to bring the water engine to market, promising that the first consumer models could be available within a few years. Though this timeline seemed aggressive, it followed the precedent of previous Tesla projects that initially faced skepticism but eventually transformed entire industries. As Musk exited the stage, the room buzzed with conversation about the magnitude of what had just been announced. Analysts, policymakers, and business leaders alike scrambled to assess what this technological leap would mean for their strategies, investments, and future directions. The unveiling of Tesla's water-powered engine was more than just an announcement of a new product. It was a statement about the relentless pursuit of progress and a challenge to the established norms of energy production and consumption. In that moment, it became clear that Tesla and Musk had once again shifted the paradigm, leaving the world grappling with the possibilities and uncertainties of this new innovation. The aftermath of this revelation would likely reverberate across industries, economies, and societies as the world waited to see whether this bold vision would become reality. The challenge of balancing energy output, efficiency, and cost must be addressed for the technology to transition from a promising prototype to a viable product. Debates among scientists were intense, with some cautiously optimistic while others warned of significant technical barriers. Even as experts debated the feasibility of Musk's claims, the potential environmental impact of the new technology became a hot topic. While the water-powered engine promised to mitigate ecological concerns associated with EV technology, such as lithium extraction and disposal, it raised questions about water resource management. The widespread use of water as fuel would require robust systems to manage and distribute water resources. Environmentalists expressed concerns about exacerbating water scarcity in drought-prone regions. Musk's mention of the engine's ability to use non-potable or seawater offered some reassurance but did not quell all anxieties. The societal impact of this technology was equally profound. Technological advancements often bring improvements but can also disrupt industries and communities. Workers in economies reliant on traditional car manufacturing, mining, and fossil fuel production could face upheaval. Transitioning to a water-based energy system would require retooling skills, sparking debates on workforce retraining, job loss, and economic transitions. Managing this shift carefully would be crucial to avoid worsening economic inequalities. Politicians and policymakers faced a wave of questions triggered by Musk's announcement. Regulatory bodies would need to respond to such a transformative technology, addressing whether new laws and standards would be necessary to govern water as fuel. This shift demanded swift and comprehensive policy development and international cooperation to ensure fair access to water resources. Legislators likely discussed the need for subsidies to support infrastructure and research, as well as strategies to manage the economic impacts on traditional energy sectors. Musk's move reignited debates over intellectual property rights in green technology. While Tesla previously adopted an open-source approach to some patents, it was unclear whether the company would do the same with the water engine. Tesla's decision would influence its market position and the pace at which the automotive industry transitions to cleaner energy systems. The unveiling of the water engine also challenged perceptions of technological progress. The EV movement was seen as a significant step towards sustainability, but Musk's announcement highlighted the ever-evolving nature of innovation. This shift encouraged industries and governments to adopt a flexible approach to investing in emerging technologies, anticipating rapid changes. Musk's bold announcement underscored the role of corporate ambition in shaping the future. His introduction of a new engine type reflected his philosophy that progress must be audacious, contrasting with the incremental advancements typical in the industry. This approach inspired discussions about whether traditional automakers and tech companies must adopt a similar mindset to remain competitive. Educational institutions began recognizing the potential impact of this new technology on curricula and research programs. Universities with strong engineering and energy departments considered pivoting their focus to this emerging field. The shift from lithium-ion battery research to water-based energy systems promised new academic opportunities, inspiring students and young professionals to pursue careers in sustainable energy innovation. The announcement also influenced consumer attitudes. Public interest in green technology, driven by climate awareness, grew significantly. The prospect of a car powered by water captivated imaginations, sparking excitement about a future where refueling might be as simple as connecting a hose. However, questions about affordability, maintenance, and integration into everyday life remained. At the heart of the excitement and skepticism was the question: how soon could Musk's vision become reality? History shows disruptive technologies reshape the world, but often face delays as prototypes evolve into scalable products. For Tesla, already stretched by ambitious projects, adding a water-powered engine was a bold undertaking. Refining the prototype for mass market readiness required overcoming numerous challenges, even for Tesla's innovative culture. Scaling production presented immediate hurdles. Tesla would need to establish specialized supply chains, source unique materials, and train its workforce. This transition required significant investment and a recalibration of operations. Building a robust supply chain for water-powered engines, possibly involving advanced electrolysis or specialized sensors, could take years, risking delays in meeting production targets. Relentless R&D efforts were critical. While the prototype showcased feasibility, refining it for efficiency and reliability was a separate challenge. Engineers had to address vehicle range expectations and ensure real-world performance matched initial metrics. Durability and maintenance posed additional concerns, with water exposure potentially causing corrosion or mineral buildup. Solutions were needed to prevent long-term engine degradation and keep maintenance costs reasonable. Infrastructure development also posed challenges. Unlike charging stations for EVs, water-powered engines implied the need for specialized refill points. Cities would need to evaluate whether their water systems could handle increased demand. Policy and regulatory frameworks would also need to evolve, setting standards for emissions, water use efficiency, and safety. This process could take years, impacting market readiness. The impact on global industries was profound. From mechanics to parts manufacturers, the shift resembled the transition from horses to cars. Educational institutions would need to adapt engineering curricula to cover water-based propulsion, ensuring a skilled workforce for the future. Consumer interest in water-powered vehicles fueled public imagination. Enthusiasts dreamed of simplified refueling at home, replacing long waits at charging stations. However, practical questions about affordability and logistics remained, adding complexity to the technology's path forward. In this blend of excitement and skepticism, Musk's announcement underscored the challenges of turning revolutionary ideas into reality. For Tesla, the journey to mass market adoption of the water engine would test its engineering prowess and strategic vision in uncharted territory. The unveiling of Tesla's water-powered engine technology marks a pivotal moment in the ongoing evolution of sustainable energy. As debates surrounding its feasibility and implications grow, it is clear that this innovation, if realized, could redefine the global energy landscape. However, the transition from concept to mainstream technology is fraught with challenges, ranging from engineering hurdles to societal disruptions. In this extended exploration, we examine these aspects in detail, shedding light on the potential future of this groundbreaking development. One of the most significant technical hurdles for the water-powered engine lies in its core functionality. Unlike electric or internal combustion engines, a water-powered system presumably operates using advanced electrolysis or similar processes to extract hydrogen or generate energy directly. Achieving the required energy efficiency while maintaining cost-effectiveness is no small feat. Early prototypes might rely on high-performance catalysts or membranes, but these materials can be prohibitively expensive or difficult to manufacture at scale. Moreover, water as a fuel source introduces unique engineering challenges. For instance, impurities in non-potable water, such as minerals or biological contaminants, can interfere with the system's operation. Designing engines that can handle various water qualities, including seawater, requires innovative solutions such as advanced filtration systems or robust anti-corrosion technologies. These added complexities could increase production costs and require ongoing maintenance, creating potential barriers to widespread adoption. Tesla's history of pushing the boundaries of engineering innovation suggests that the company will invest heavily in research and development, R&D, to overcome these obstacles. However, success will depend on collaborative efforts with material scientists, chemists, and engineers, specializing in fluid dynamics and thermodynamics. Universities and private research institutions could also play a crucial role, contributing to breakthroughs that make the technology viable for mass production. The introduction of water-powered engines could disrupt several key industries. For starters, the automotive sector would need to undergo a fundamental transformation. Manufacturers of traditional internal combustion engine, ICE vehicles, would face declining demand, much like what has occurred with the rise of electric vehicles, EVs. This transition could result in job losses and economic challenges in regions dependent on ICE production. Similarly, the battery industry, which has boomed in response to the EV revolution, might experience a downturn if water-powered technology becomes the dominant form of propulsion. Lithium, cobalt, and nickel, critical materials for battery production, could see a decline in demand, impacting countries and companies that rely on their extraction and sale. While this might alleviate the environmental damage associated with mining these materials, it could also create economic instability in mining-dependent regions. On the other hand, new opportunities could emerge. The demand for components specific to water-powered engines, such as electrolyzers, advanced catalysts, and water purification systems, could stimulate growth in other industries. Companies that adapt quickly to these changes, whether through retooling their facilities or investing in R&D, stand to gain a competitive edge. Governments could also play a role in mitigating economic disruptions by providing subsidies for retraining workers and supporting industries that pivot toward water-based energy technologies. The lessons learned from the transition to EVs, where targeted investments in charging infrastructure and incentives helped accelerate adoption, could be applied to water-powered vehicles as well. From an environmental perspective, water-powered engines hold significant promise. Unlike traditional ICEs, which emit greenhouse gases, and EVs, which have an environmental cost tied to battery production and disposal, water-powered engines could drastically reduce the automotive sector's carbon footprint. If the system relies on electrolysis powered by renewable energy, the entire life cycle of the vehicle could be nearly emissions-free. However, widespread adoption of this technology could create new environmental concerns. The increased use of water as fuel might strain existing water resources, especially in regions already facing scarcity. While Musk's claim that the engine could use non-potable or seawater is reassuring, questions remain about the energy and infrastructure required to process these water sources at scale. For instance, desalination is energy-intensive and could offset some of the environmental benefits if not powered by renewables. Water distribution systems would also need to be evaluated to ensure equitable access. In areas where water infrastructure is underdeveloped, such as parts of sub-Saharan Africa or South Asia, the introduction of water-powered vehicles might exacerbate existing inequalities. Addressing these issues would require international cooperation, with governments, nonprofits, and private companies working together to develop sustainable solutions. The emergence of water-powered technology would necessitate a rapid evolution of policy and regulatory frameworks. Governments would need to establish standards for engine safety, water quality, and emissions, even if they are primarily steam or non-toxic byproducts. These regulations would have to balance encouraging innovation with protecting public health and the environment. On a global scale, the geopolitics of water could take on newfound significance. Countries rich in freshwater resources might gain strategic advantages, much like oil exporting nations did in the 20th century. Conversely, regions with limited access to water could face heightened competition, potentially exacerbating tensions and conflicts. To mitigate such risks, international organizations like the United Nations or the World Bank might need to step in, developing treaties or agreements that govern the equitable use of water as a global resource. Additionally, governments could incentivize the development of technologies that minimize water use or rely on alternative sources, such as atmospheric water generators. The success of water-powered vehicles will ultimately depend on consumer acceptance. While the prospect of eco-friendly, water-fueled cars is appealing, several practical considerations could influence adoption rates. These include the cost of the vehicles, the availability of refueling infrastructure, and public perception of the technology's reliability. For consumers, the idea of refueling at home using tap water could be a game-changer, eliminating the need for trips to gas stations or charging points. However, this convenience would depend on the affordability of the vehicles and the infrastructure needed to support them. If water-powered cars are significantly more expensive than EVs or ICE vehicles, adoption could be slow, especially in price-sensitive markets. Educating the public about the benefits and limitations of water-powered technology will also be critical. Misinformation or unrealistic expectations could lead to skepticism, much like the initial reception of EVs. Tesla's marketing efforts, combined with endorsements from environmental organizations and industry experts, could play a crucial role in shaping public opinion. The advent of water-powered technology will have profound implications for education and workforce development. Universities and technical schools will need to adapt their curricula to prepare students for careers in this emerging field. Engineering programs might introduce courses on advanced electrolysis, water resource management, and sustainable energy systems, while vocational schools could offer training in maintaining and repairing water-powered engines. For workers in industries disrupted by the transition, retraining programs will be essential. Governments and private companies could collaborate to provide opportunities for upskilling, ensuring that affected employees can transition to roles in the new energy economy. This could include positions in manufacturing, infrastructure development, or research and development. Beyond the technical and practical considerations, Musk's announcement has sparked broader philosophical questions about the nature of progress. The EV revolution was seen as a definitive step towards sustainability, yet the introduction of water-powered technology challenges this narrative, illustrating that innovation is a continuous process. This dynamic underscores the importance of maintaining flexibility in how societies approach technological advancement. Governments, industries, and consumers must be prepared to pivot as new breakthroughs emerge, prioritizing long-term sustainability over short-term gains. It also raises questions about the role of corporate visionaries like Musk in driving progress. Should such transformative innovations be left to private companies, or should public institutions play a more active role in shaping the future? The transition to water-powered vehicles could have far-reaching geopolitical implications. As water becomes a critical resource for transportation, nations with abundant supplies may find themselves in positions of increased influence. This could reshape international relations, much as oil and gas have done in the past century. However, the global community must ensure that this shift does not exacerbate inequalities. International cooperation will be essential to developing equitable systems for managing water resources, distributing technology, and addressing environmental impacts. Organizations like the United Nations could lead efforts to establish frameworks that promote sustainable development and prevent exploitation. As Tesla embarks on the journey to bring its water-powered engine to market, the company faces a monumental task. From overcoming technical challenges to navigating complex regulatory landscapes, the road ahead is anything but straightforward. Yet, the potential rewards, both for Tesla and for the world, are immense. If successful, this technology could revolutionize transportation, reduce greenhouse gas emissions, and set a new standard for sustainable innovation. However, realizing this vision will require collaboration across industries, governments, and academia, as well as a willingness to confront the societal and environmental challenges that come with such transformative change. The transition from fossil fuels to cleaner energy sources has been a long-standing challenge for humanity. Historically, energy transitions, such as the shift from coal to oil and later the introduction of electricity, have reshaped economies, geopolitics, and industries. If water-powered engines prove viable, they could represent the next great leap in this evolution. Unlike oil, coal, or even electricity, water is a more universally available resource, albeit with challenges related to distribution and quality. This universality positions water as a democratizing energy source that could reduce dependency on oil-rich nations and lessen the geopolitical tensions associated with fossil fuel markets. However, this transition requires careful management to avoid creating new disparities in access and infrastructure. A potential byproduct of the water-powered engine's development could be the acceleration of the broader hydrogen economy. Hydrogen, often described as the fuel of the future, faces challenges related to production, storage, and transportation. If Tesla's engine incorporates hydrogen generation through water electrolysis, it might spur advancements in these areas. Breakthroughs in hydrogen storage or safer fuel cells could cascade into other industries, such as aviation, shipping, and heavy machinery. Moreover, the technology's adoption could drive parallel innovation in water utilization, including more efficient desalination methods and atmospheric water harvesting systems. These technologies, while supporting the energy transition, could also address broader global water security challenges. The global automotive industry, valued at trillions of dollars, has been in the midst of a revolution driven by EVs. The introduction of water-powered vehicles represents another seismic shift. Traditional car manufacturers will need to invest heavily in R&D to stay competitive, potentially collaborating with or acquiring startups specializing in water-based propulsion systems. The widespread adoption of water-powered vehicles will necessitate an overhaul of fueling infrastructure. While some existing gasoline stations may be repurposed, the logistical requirements of water stations differ significantly. They must integrate advanced filtration systems to accommodate different water qualities, ensure proper drainage systems for waste management, and potentially include on-site desalination capabilities for coastal areas. This infrastructure transformation could generate significant opportunities for construction companies, water technology firms, and civil engineers. Urban planning may also need to evolve, particularly in areas prone to water scarcity, where vehicle refueling demands could compete with municipal water use. As with any technological breakthrough, the rise of water-powered vehicles will necessitate a reshaping of the job market. While jobs related to traditional internal combustion engines and lithium-ion batteries may decline, new roles will emerge in areas such as water systems engineering, advanced materials research, and maintenance of water-powered engines. Thanks for watching. If you enjoyed this video, make sure to hit the like button and subscribe to our channel for more updates on groundbreaking technologies and the future of innovation. Don't forget to click the notification bell so you never miss an upload. We'd love to hear your thoughts. Drop a comment below and let us know what you think about Tesla's water-powered engine. Could it be the future of energy? Let's discuss. Thanks again for tuning in, and we'll see you in the next one.